Hi, Mrs. B here. Let's review for the Chapter 5 test. Remember to try the problems by pausing the video and then play the video to check your answers with mine. Okay, here we go. Okay, so for 5.1, we learned about ratios and rates. For ratios, we first write, when it says to write it as a fraction, we write it with the first number on top as our numerator, and then we have to simplify fractions. So this would be 4/5. Same deal for the second one. We have 24/9 that simplifies to 8/3. Okay, we're going to find unit rates. So for this one, we have to take our money and divide by cans. Notice I put approximately equal to, because we had to round that money to make it make sense. It would be 23 cents a can. Okay, so for the next one, we're comparing our rate to our friends. Our friends is already in miles per hour, so let's put our rate, your rate, in miles per hour as well. So you would take your miles and divide by your hours. So now we would have 2/3 divided by 1/4 is the same as multiplying by the, multiplying by 4 over 1, and that would be 8/3. So your rate is 2 2/3 miles per hour. So you are the faster hiker, and by how much? 2 2/3 minus 2 1/3 is that you're faster by 1/3 a mile per hour. Okay. We have to find the unit rate from the graph. So we can take one coordinate pair. I'm going to pick the smallest numbers, and what that means is that we have 11 feet in 2 seconds. So we have to find out how many feet that is in 1 second. So 11 divided by 2, that's 5.5 feet per second. Okay, in 5.2, we compared ratios to see if they formed a proportion. So when we have the first one with 10/18 and 45/81. Both of those fractions simplify to the same ratio, 5/9. So they do form a proportion. Okay, so for the next one, we're comparing your 3 laps is to 1.5 minutes, and is that the same as 24 laps in 12 minutes? So we can use cross products to decide, and both of our cross products are 36. 12 times 3, and 15 times 24. Both are the same product, or we could have turned them into unit rates to see that they are the same unit rate. So either way you do it, the answer is yes. Okay, and we can see from a table if we have a proportional relationship by comparing all the ratios. So in this case, is 4 over 1/2 the same as 8 over 1, the same as 12 over 1.5, the same as 16 over 2. They're all equivalent ratios, so that means that yes, we do have a proportional relationship. In 5.3 and 5.4, we wrote and solved proportions. So for the first group, decide what is your best method. We learned 3 different methods. In this case, I look at my denominators, and I can easily multiply 3 by 4 to get an equivalent ratio. So let me do the same to my numerator and multiply 5 times 4 to get that C is equal to 20 in this case. Sorry, my computer again. Okay, and for the next one, I would use cross products for this one. So we have 4 times u is equal to 3 times 6, which is 18. So we have to divide each side by 4 and simplify it. 18 fourths is 9 halves. 9 halves is 4 1/2. Okay, let's look at the pencil problem. This would be the proportion you could use to solve that. Make sure you put your units next to it so you sort out your numbers correctly. So now we have to solve it. I would, again, I would probably use a unit rate in this case because we could simplify 36 over 3 to 12 pencils in one box. So then it's easy to multiply by 5 to get our answer. So 12 times 5 would mean that we would have 60 pencils in the bigger box, in 5 boxes. Okay, so let's see. So this is the type of problem where we know the parts. We know the part that's adults and the part that's children, but we have to scale it up for a larger number. So I make a chart. For every 5 adults, there's 3 children, so that's a group of 8 people. And now let's see, what do we have to multiply 8 by to get to 144? Well, we can take 144 and divide it by 8 to get that number, which is 18. Computer. And then we have to multiply each part by 18. But they only ask us about the adults. I'm only going to multiply 5 by 18. And there must be 90 adults in that group. In 5.5, we found out how to get the slope of a line. So for getting the slope of a line, we have to take our y values and subtract them, find the difference for the numerator. And for the denominator, we take our x values. Notice we have, in each case, we have 5 plus 2 over 5 plus 2, which is 7 over 7, which ends up being 1. So the slope of that line is 1. You could also graph it to see that the rise is 1 and the run is 1 for that graph. Okay, let's look at our next one. So for this one, pretty easy to see that it's directly proportional, so we're just subtracting by 0 each time. So we have 2 over 6, which is going to be 1/3. And then for B, we have our y's are 5 and -1, so 5 minus -1. And our x's are 2 and -1, so 2 minus -1 for the denominator. So we end up with 5 plus 1 over 2 plus 1. So we have 6 over 3, which simplifies to 2. So the slope of that line is 2. Okay, for number 5, they ask us to find the slope of the line and then interpret what does that slope mean in the context of this graph. So for our slope, we also have a direct proportion, so I would definitely use 0, 0 as one of my points, and the other point, I picked the smallest one, so 40 and 1. So we end up with a slope of 40. And what that means is that for every week, so in 1 week, we've saved $40. So we would write that as a unit rate, that it's $40 per week in savings. Okay. In 5.6, we talked about those proportional relationships that have a special name of a direct variation. So we have to tell from a table whether we have a direct variation. What you want to do is see if all of the ratios are equal to each other, the ratios of x to y. So is 1 over -1 going to be the same value as 3 over 1 or 4 over 2? No. So that does not form, that is not a proportional relationship. And then when we look at B and do the same thing and compare the ratios, they're all equivalent. So that means that there is a proportional relationship. That we can always take X and multiply it by some number K to get to Y. Okay, and we have to be able to tell also if from an equation whether it's a proportional relationship. So let me start us out here with A. So it has to have that form of Y equals some number times X to be a proportional relationship. So, oops, this is supposed to be an equal sign. Okay, so we have this equation and we want to just try to make it look like a proportional relationship, so we would add 6 to both sides to get Y by itself. So that would give us Y equals 3x plus 6. Notice it is not of the same form as a proportional relationship because of that fact that we're adding 6. That gets in the way of it being a proportional relationship. So the first one is not a proportional relationship. Okay, and then for our second one, let's solve for Y again. So we're going to divide each side by 4. So now we have Y is equal to X divided by Y. I'm sorry, X divided by 4 is the same as 1/4 times X. So notice that X is being multiplied by one number, K. That's the number that relates X to Y. So that tells us that it does follow the rule for being a proportional relationship. So that would be a yes. Okay, I hope you did well with the video. If you, on your test, draw a picture of a snowman at the end of your test, you will get a bonus point. Okay, thanks a lot for doing the video. Take care.